Welcome back, everybody. Welcome to the Trig unit, one of my favorite subjects to teach. We will be looking at later on next unit word problems, real life problems involving this. So hopefully by the end of this unit, you'll be able to identify the parts of a right triangle, be able to identify which trig ratio to use, be able to solve for missing sides, angles, and right triangles. You can read down through some of the important vocabulary there. So hopefully by the end, you'll know what each of those means. So if you would like to watch a little fun video, there's a link. You don't have to. So first of all, we need to learn how to label triangles, how to label right triangles. Now, we've already learned that a right triangle is made up of two legs and a hypotenuse. So let's say down here in the bottom left that we're looking at angle A. Okay? We always start by circling the reference angle. When we're looking for a side, there's going to be an angle given. Later on, when we're looking for an angle, there'll be an angle we're looking for. Okay? So first thing we do is label the hypotenuse. That's always across from a right angle. And then we go to our reference angle. If this was angle A, across from that, or opposite that would be the opposite leg. And you'll usually just see me put O. And then what's left over is the adjacent leg. So that's the leg that's kind of part of that angle. If I look here and I say this is our reference angle, here's my right angle. So across from that would be my hypotenuse. Across from my reference angle would be my opposite. What's left over would be adjacent. Now notice if I would change my reference angle to like this one, the hypotenuse stays the same. But if I'm looking at this angle, this becomes my opposite leg, and this becomes my adjacent leg. So when you're labeling, I would always try to do it in that order. Circle your reference angle, find the hypotenuse, find the opposite leg, what's left over is adjacent leg. Okay, so here's my reference angle. Across from right angle is hypotenuse. Across from my reference angle is my opposite leg. What's left over is adjacent. So now we have three trig ratios. We have sine, cosine, and tangent. And if you ever take trig later on, you'll learn some more things. So the sine, all of these are ratios, trig ratios. The sine is the opposite leg. Sorry for the typing or writing over the hypotenuse. Okay, we're going to call that basically just O over H. So we either use it when we know O and want H, or when we know H and we want O. Okay, so that is sine, O and H, O over H. Cosine is going to be A over H, so adjacent leg over hypotenuse. We use that when we either know A and want H, or we know H and we want A. Tangent is going to be opposite over adjacent, opposite leg over adjacent leg. So when we know O and want A, or when we know A but want O. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So let's look at some examples here. So here is, we circle our reference angle. Like I said, there's our reference angle. It's this angle right here. So we label our hypotenuse. We go opposite here. That's our opposite leg. What's left over is adjacent. So in this problem, we want H and we know O. We want H and we know O. So that would be sine if we go back to the last page and look. So how we're going to set this up is we're going to say the sine of 73. Remember, it was O over H. So O goes on top, H goes on bottom, which was X. So what we do is we get our calculator and we type in sine. There should be an SIN button. Sine, so it's actually sine, but the abbreviation is SIN. Sine of 73. I'm going to use 3 decimal places here. That is 0.956. And that equals 12 over X. So what I do to solve this is I put over 1 and I cross multiply. So I get 0.956x equals 12. Okay. So to get the x by itself now, I would divide 0.956 and I would get x equals 12 divided by 0.956. I can use one decimal to end it, or the 10th, 12.6. Now the x can be on the top or the bottom. It doesn't matter. It just depends which one it is and which trig grade you're using. So let's look at some more examples here, and I'm going to zoom in. Okay, so for this one, going to be very similar to the last one I did actually. There's my reference angle. Across my right angle is my hypotenuse. Across from my reference angle is my opposite. What's left over is adjacent. So I know H and I want O. Okay, so I'm going to use sine again. That was the one with O and H. So the sine of 72, now notice it's O over H. So this time it's going to be x over 18. So sine of 72, 0.951. Okay, so I put that over 1 and I cross multiply. Now notice here, when I do x times 1, I just get x equals. So I don't have that extra step of dividing. Then I do 0.951 times 18. And I get 17.1. So that would be my final answer. If I go down here, here's my reference angle. Across from my right angle is my hypotenuse. Across from my reference angle is opposite. What's left over is A. So I know O and I want A. So the one that involves O and A was tangent. So the tangent of 45 equals 12 over x because it was O over A and the O is 12. Now, tangent of 45 is going to be something special. It's just going to be 1. I get that. So cross multiply. For this one, I just get x equals 12. And we could think about why that is. It's an isosceles triangle. But we don't have too much time to go into that. Okay, the last one here. Here's my reference angle. This would be my hypotenuse. It's across from the right angle. This would be my opposite. What's left over is adjacent. So notice I care about A and H. I want A. I know H. So that's going to be cosine. So the cosine of 30 is going to equal adjacent, which is x, over hypotenuse. Cosine is adjacent over hypotenuse. So into my calculator, I type in cosine of 33. I get 0.839. Remember, 3 decimals at this point. So that equals x over 18. So I put that over 1 and I cross multiply. It is a little bit easier because the x is on the top, but it's not always going to be on the top. Then I do 0.839 times 18, and I get 15.1. So that's kind of solving for a missing side. Now, when we're solving for an angle, it changes a little bit, but not too much. So just remember, when we solve equations like this, we're trying to undo operations. We're trying to get the x by itself. So the opposite of adding 4 is subtracting 4 here, and I would get x equals 8. The opposite of 6 times x, so the opposite of multiplying by 6 is dividing by, so I would get x equals 8. So when trying to undo, to find an angle, I need an inverse operation. So we don't really change much. We still circle our reference angle. In this case, that's the angle we're looking for. I label my hypotenuse. I label my opposite, and what's left over is A. So notice here, instead of wanting a side, I know O and I know H. O and H was sine. So here's how to set this up. If I call that angle X instead of question mark, O goes on top, H goes on bottom. So instead of cross multiplying, really what I want to do is undo this sine operation. So what I'm going to do is do the sine inverse of 5 over 6. Now for most of you in calculator, that's going to be like a second button or a shift button. On mine it's a shift and then I hit sine. Okay, and it should come up like sine -1. Some of them may say arc sine or a sine. Then I just type in 5 divided by 6. So sine inverse, that's what that sine -1 means. Sine inverse 5 divided by 6 is 56.4. Remember, I was looking for an angle. So that's degrees. Right, for the next one, here's the angle I'm looking for. This would be my hypotenuse. This would be my opposite. What's left over is adjacent. So I know O and A. So that would be tangent. Remember, O went on top, O over A. So X would equal the tan inverse. I'm looking for an angle. So if you're looking for a side, just use the normal. If you're looking for an angle, use the inverse. So I type in second tan, 37 divided by 29. And I get X equals 51.9 degrees. Okay, so just a few more examples here. For number 7, here's the angle I'm looking for. Across from my right angle is hypotenuse, and I'm actually going to zoom in a little bit here. Okay. Across from my reference angle would be opposite. What's left over is A. So this is an A and A1. That's cosine. So the cosine of my angle, which I don't know yet, cosine is A over H, so that would be 35 over 43. So X would equal cosine inverse of 35 over 43, which is 35.5 degrees. So there's one example of each of them. Now sometimes we may know all 3 sides. So if that's the case, I can still circle my reference angle. I can label everything. And then I just choose whatever one I want to use. Okay, so maybe I'll use sine. So the sine of X, remember sine is opposite. That would have been 63 over hypotenuse, 7. So I can solve this. It shouldn't matter. I could have used tangent. I could have used cosine. I should have got the same thing. Okay? And I don't really have time to show that right now, but you would get the same thing no matter which trig ratio you use. That's if we know all 3 sides we can choose. So as always, I would encourage you, email questions, come in person and ask, pause, rewind, look it up in sources. But hopefully that helps. You can practice the rest of these problems and then check your answers. Have a good day.